Hello and welcome to the second session of Flow Control in Java video series. In this session, we will first cover the remaining points related to the if-else statement which were left in the part 1 of the flow control. So let's quickly complete those points or cases. So the cases are, this was the program which I was about to discuss. So in this program what we have boolean type over there, and we were discussing the if else statement. So consider this as the second part, and please watch part 1 before really proceeding with this session. In this session we will also discuss about the switch case default statements in Java. So what we have in this program is that we have a variable identifier b which is of type boolean, and we have given it a value true, but in the argument of if block we have assigned the value false to b. So the argument which is inside b if is now false, right? And when this is false, this part will not be executed, and the else part is the one which is going to be executed. So hence we have hi is onto the screen, or hi will be printed onto the screen in this way. Of course this is a boolean type, so it's not gonna flag any kind of incompatibility. So let me quickly run this. Bad typer. Anyway, so this is perfectly fine, and this is running. Say hi is onto the screen now. So this is one thing related to the boolean type arguments in the if block. Then the next one is, we have a program over here. Let me quickly copy this, and after copying this, pasting it over here and saving the program at the same time. In this program we have a comparison operator over there. Remember, when this is a single equal sign, then it's the assignment operator. Assignment operator means that the thing which is on the left side of the equal will be assigned to the thing which is on the value which is onto the right side of the equal will be assigned to the value which is onto the left side of the equal, right? And double equals is nothing but the comparison operator. So it compares two things, compares right with the left, right? If it matches, then it's true. If it doesn't matches, then it's false. So in this case we have b as false, and we are trying to compare false with false, right? B is false, so false is equals to false, yes. So this becomes true. That's why hello will be printed onto the screen and not hi, because of the confusion that false is there. We are passing false, right? So hello will be the output in this case. I have saved this code. Now let me quickly compile it, because I have changed the file contents, and now running it, it will give me hello onto the screen, which is over there, right? So that's why this argument is right. Now moving on to the next point, we have passed int x is equals to 0, and then we are trying to do if x. Now this x should be a boolean type, and we are passing an integer, so it's gonna give us the compatibility issue first. So let me quickly save it, and it will show that required is boolean and found is int. This is the error, right? So this is a very easy program. Now let me take the next one, save it as well. Now in this program what we have done is, I have passed true as the argument. True is a reserved literal. Remember, literals are the values, right? So true is a value, like 1, 2, 10, 100, 1000. True is also a value, and true is a value related to the boolean type, and we know that the argument type related to if is true. So true is the value passed on to the if. So that's why this is right, or this is okay with if block. Now this semicolon never comes with this syntax, right? But from the previous videos from the previous session of if else statement, we know that semicolon is a empty statement. It's an empty statement. It doesn't do anything, but it is a statement. So we are not having the curly braces. These are optional, but then only one statement which comes just adjacent to the if argument will be considered the statement inside the if block. So that's why this is coming just after the if. It will be considered inside the if, and we from this we find that if it is true, it's not going to do anything, right? So what will happen? Nothing will be printed on the screen, and this is the right thing to do. This is right syntax. It's not gonna flag any kind of compile time error. Wow. So see, nothing is onto the screen for compile time. No runtime exceptions are there. So it's a perfect code, right? Now the next thing is we have the next code over here. It says that we have if true, right? And then this is a declarative statement. So in context of declarative statement, we know that if we are trying to declare something inside the if block, then it should be having the curly braces. If there are no curly braces, then the statement which come after the assignment or argument of if should not be a declarative statement. So that thing over there is wrong to do. So to prove this, let me quickly clear this first and then compile it, and we will get the compile time error. This is not the right thing to do, as this is flagging the error. Now to improve this or to remove this, we have to apply the curly braces, and as soon as we apply the curly braces and try to recompile it, see there is no error related now. So this is the condition related to the declarative statement. We cannot declare declarative statement if we are not using the curly braces. So these are some of the points which were left in the previous video session, and now let's begin with the topic of switch case default. We already know that the looping has three types of categories, and we were discussing the first category, which is the selection statement, and we have given the definition of selection statement. In selection statement we have also described two more categories, subcategories actually, and the subcategories were if else statement, which we have discussed and completed right now, and the next category was switch case default. So let's begin with the category of switch case default, and to begin with, let me close this one. What I'm going to do is let me quickly shift it over. Right. So to begin with, let's open the slide and hit run. Now switch case default, when to use it and what's the significance of using switch case default, what are the syntax related are some of the questions that are we are going to answer in this video session. So say you have a scenario where you want to choose between head and tail. So in that case, because you have two options, you can choose the if else statement. But when you are going into a situation where you have multiple choices available to you, for example, you have grading systems in your academic sessions where you provide grades to the marks. For example, when you score more than 90, you give the student an A grade, and when the marks are between 60 and 50, you call that as D grade, right? So you have grading system according to the marks. So you manipulate those system by using the slabs. So the choices increases, and if you try to calculate and elaborate those choices in if else block, you will find that the code is getting messy, and it becomes difficult to read and maintain the code. For example, if I try to get the marks of a student from the database, and say if some student has 65 marks over there, and I want to give the grade related to that marks, then what I have to do, I have to write a statement where if I have to first check up whether the marks are 90 or not, then I will check up whether the marks are between 80 and 90, and then afterwards we will check for the range where it will fall, and then we will provide the grades related to that. So to do that, if else statement is gonna have a lots of multiple blocks inside else and then ifs. So that's why the code is going to be a little crowded, and we cannot clearly read the code. And say if after some time the grading system changes, then it will become very difficult for us to maintain that code. For example, if at 10 places I try to improve the code and I forgot to mention the same at the 11th place, then it will be hard for me to maintain that code. I will have to recheck the code the 11th at all the places once again. Not that I have changed the code at 10 places, so I am out of 10 places now. No, if there is an error, I have to check the whole program once again, and it becomes burdensome. So to avoid these types of situation, we have another scenario of selection statement which is known as switch case default. So if several options are available, then it is not recommended to use if else statement. We should go for switch statement. Why? Because it improves readability of the code. This is the best reason for now. It's not the debate over here that which is better, the switch case default or the if else. Both of these statements have their own pros and cons, and but when it comes to multiple options, switch case default is a better option compared to the if else statement. So that's why we should go for the switch case default statement to improve the readability of the code. And when the readability of the code improves, it becomes easy to maintain the code as well in future as well. Next is the syntax related to the switch case default. So according to syntax, we have a switch keyword, right? And then the arguments are x. And this x can take multiple data types in it. Although the range is fixed, we will discuss about the data types that x can take. And then this x is connected to these cases, right? This is case, and then we have case 1, right? It's not necessary to have case 1. We can write down many other things over there in place of 1, but for now consider the simplest of the scenarios where I have written down case 1, and then related to the case we have an action. Similarly, we have case 2, and then related to that case we have another action, or say action 2. And similarly, we can have multiple number of cases, hundreds of cases available to us, and the actions that are related to those cases. In the end, we have a default case and a default action. We will be discussing all these things in great details in this video session, hopefully. Now, so this is the basic syntax related to the switch case default. Now we have to discuss about the x, the cases, and the default. So let's begin with the topic. Until 1.4 version, the allows data types for the switch argument are byte, short, char, and int. So for 1.4 version, the allowed data types were byte, short, char, int. So it means in place of x, you can use either byte, short, char, or int. It's up to you whatever you want to use, but up to 1.4 version. With the enhancement of JDK, that is Java Development Kit, in version 1.5, the wrapper classes of these types were also introduced inside this switch argument. So from 1.5 version onwards, we can use byte wrapper class, short wrapper class, char wrapper class, or the character wrapper class, and integer wrapper class, along with these 4 data types as well. So from version 1.5 onwards, the corresponding wrapper classes and enum types are also allowed. So the tally is increasing now. So if I take the diagram and see what are the enhancements related to the argument of the switch statement, it is for this x we can use byte, short, int, and char, but it is applicable to 1.4 version. With the enhancement, that is in version 1.5, we can use enum, we can use character, integer, byte, and short wrapper classes as well. And in 1.7 version, we can use the string classes as well in place of this x. So when it comes to if else, we are limited to boolean only, but when it comes to switch case default, we have extended our argument type range, right? So that's why switch case is more flexible compared to the if else statement as well, and it improves the readability of the code also. Now let's move on to the next point. Curly braces are mandatory. Remember, we have seen that switch case comes with the curly brace like this over here. So these curly braces over here are mandatory. Remember, in case of if else statement, the curly braces were optional, but there were conditions related to the curly braces. But in switch case, curly braces are mandatory. So this is one thing related to the switch case default statement. Now this is mandatory except switch case. In all remaining cases, curly braces are optional, right? This is mandatory for switch, but when it comes to cases, you may have the curly braces or you may not have curly braces. So what I'm saying is that inside the case over here, it may have a curly brace over there, over there, over here, over there, over here, but it's optional. Whereas these curly braces, which are related to the switch, are mandatory. So let's move on to the next point. Both case and default are optional. See, we have inside our switch the case statement and the default statement. So it's not necessary to mention case and default inside switch. So what's the minimum code length that we can have in case of switch case default scenario is switch and then an argument type, a valid argument type actually, and then two open curly braces and closing curly braces. One opening and closing curly brace will be enough to provide you the syntax of the switch case default scenario, right? Let me run a program. Now in that, what can I have is, right, see, this is second part, right? Now I have also listed down the output over there, right? Now copy and paste the program over here. In this scenario, we have the simplest of the switch case default. Now one thing over here is inside the switch case, what I'm doing, I am printing something onto the command prompt inside switch. But when you notice down the point related to the switch case scenario, you know that every statement inside switch must be under some case or default. It means we cannot have independent statements inside the switch. It should be either inside case statements or it should be either inside the default statements. If you try to do like this as on the screen, you will get the compile time error because this statement is neither inside the case statement or the default statement. So that's why we are gonna get an error. Let's see what the error message is. Now I compile it and I'll find, okay, see how many errors we got. We got 6 errors, and it says this. See, it's pointing to the line where the error is coming, right? This is the point. So we cannot do so. So to successfully or to correctly compile the program, what we have to do, we can do is, we for now comment out the line and we will see that the program compiled very much fine. So let's move on to the next point. Every statement inside switch must be under some case or default. This is a very important point. Also, case and default are optional. Now next point is every case label should be compile time constant. So what is the case label? We have seen in the slide that case 1 over there. So this 1 over here is known as the case label. This 2 over here is the case label. So what the point says is that we must have the case label as the compile time constant. So at the time of compilation, the case label should be converted into a constant, right? If it is not a constant, then it's gonna give us the compile time error. Let me see if there is a program related to this point, and we have one point over there. See, this is the program. I quickly save it. Now if you see the program, you have the value of x as 10 and value of y as 20. We have declared y and x as int, and we are passing x, that is integer, and it is legal. It is legal to pass the argument as int in case of switch, right? So x is passed, so 10 is passed onto the switch, right? Now this 10, this is case label, this is constant, so this is perfectly alright with the Java compiler, and it will print the 10 if case matches with this x, right? If 10 comes over here in this x, it will find that okay, we have a case 10, and then it's gonna execute the statement related to it. Remember, these colons are necessary. This is the part of the syntax that we must type in order to avoid the compile time errors or the syntax errors, in other words. Now in the next case, we have case and y over here, right? This y is a variable, right? Because we do not because this is not a constant. Y is a variable over here. It has the tendency to change. It has the capability to change. That's why this is not the compile time constant, and the compiler is gonna flag the error stating that it is not the compile time error. So sorry, it is the constant expression is required. That will be the error that we will get over here. Let's quickly run this and see that we get the same error right over there. Constant expression is required. So if you want to remove this, what you can do is either you should put in some constant, or you can declare the y as a final, because final keyword has the power of changing the variable into a constant. Remember, in case of Java, if you want to convert something into a constant, then you must use the final keyword over there. This is the point you should note. So you use final in front of y and it will become a constant. So rather than treating this as a y now, this y is now treated as a constant. And when it is a constant, the Java compiler is going to take the value as 20 in here and print 20 if we pass on something onto the argument which matches with this y, right? So what's going to happen now is that the compilation is removed. Compile time error will be out and it will compile fine. See, this is the output over there. Now if I run this, see, if I run this, what's going to happen is I'm passing x is equals to 10. So 10 and 20 both are printed onto the screen. So let me discuss this point with you as well. Say we have passed 10 but we are getting 20 as well onto the screen. So what happens is Java compiler at runtime matches with the constant, case constant, right? And when it finds one, it's gonna print it. And as soon as it matches with any case, from that moment onward, it will execute each and every statement inside the case up to the default statement, right? Once the default statement is over, then the switch case default will come out of that loop. The program execution will come out of that loop. So this is one thing. So that's why when it matches with 10, it's gonna print each and everything post this point, right? From there, it's gonna print each and everything. So that's why 10 is printed onto the screen, as well as, although case y is not matching, it's gonna print 20 as well. So each and every case will be executed from this point onwards, or from the point where the cases match. For example, in case of y, the case will match only at 20, so 10 will not be printed onto the screen, right? Because it has checked it up and it finds that it's not matching. So it will come to the next line and it will find that okay, y is the one which is matching, so that's why 20 will be printed on the screen and it will come out of that switch case default loop. Now let me quickly compile this and see if it's running fine, and you will see that 20 is onto the screen compared to 10 and 20, which is the scenario related to x, right? Now moving on to the next program, we have final over there, right? So this is what we have discussed already. Now the next point states that, right, let me go to the next point. Next point states that both switch argument, that is the argument which is just adjacent to the switch keyword, right, and case label can be expressions. They can be expressions, but case label should be constant expression. Remember this point, this is very important. Switch argument may vary, but the case label should be a constant, as this is discussed also in point second. So to add to this point is that switch argument can be expression as well. We have switch x, so x is the expression, but we cannot have case x because it's not compile time constant. To make it constant, we can use final keyword and then we will use the variable y. Actually it's not a variable anymore if you use the final keyword. So let me quickly go to the program and show you how the things are working. So copying the program and pasting the program. In this case we have the expressions in case of switch arguments as x plus 1. We have declared x over there. Remember in the previous example, what we have done is when we have the x over there and when we try to access the case using the statement y, we got the error, right? So similarly, we have to use the expressions, but those expressions should calculate to a constant expression, should calculate to a constant in simple words, right? So this is one thing. Now over here we have x is equals to 10. As soon as 10 is onto the 10 comes here, it will be 10 plus 1 becomes 11. So it doesn't match with any of the case. It's the case 10, whereas this is case 30. 10 plus 20 is 30. So this is case 30, and this is case 60. Let me write down the statement over here, right? And this statement is for 60, right? Now I save the program, and just to show you that none of the cases are being executed, let me compile this, and after compilation when we run this we are not getting anything. But say if I pass down 59, because 59 and plus 1 makes it 60, so if it compiles and calculates the expressions correctly and runtime exception is not there, we'll find 60 onto the screen as printed, right? So match case is the 60th one, and as soon as it matches, it finds that okay, this is what we have to do. So it matches and it gets away with the execution. Now say if I change this value to 9, what I'll find is that it's gonna add 1 to it and it will become 10. So after matching with 10, what's gonna happen is it's gonna execute each and every statement inside the switch block. So this case will be executed, but because there is nothing to be printed onto the screen, it will be left as is. Let me write down 30 over there, so that it becomes clear that 30 will be onto the screen as well. 30 space and 60, right? Now if I recompile the program and run it, we'll find 30 and 60 as the output, right? So this is the thing related to the expression, constant expression. So the switch argument may have an expression which may not calculate to a constant, but case label must be a constant. It should calculate to a compile time constant, else the compiler is going to flag the error stating that constant expression is required. Now moving on to the next point. Of course in this program, because this is 11, no case matches, that's why no output will be there. So if I try to do so, what's going to happen is we have to compile and see if it's running, and we will find no output as the result. Now moving on to the next point. Take this one. Right. Now copying the program, saving it, and let's discuss the program. Now we have byte. We can pass the byte type of data type inside switch. We have discussed this, right? So we can pass this argument, and it's okay with switch. But let's see if byte b equals 10 and we are going to pass 10. So 10 will be caught over here and 10 will be printed on the screen. Now because we have one case match, then every statement after post this will be executed, and what's going to happen, we will have 100 onto the screen as well and 1000 onto the screen as well. Let's quickly see this and see if it's really working. Oops. So compiling, and we got error. See the error. The error is possible loss of precision. See, the possible loss of required is byte and found is int. So this is something which is not which was not expected. So how can we explain this point? See, the simple thing is over there what we have is a byte. Sorry, over here we have a byte, and in this argument as well we have a byte. But in here this compile time constant is gonna be an int, right? It's an int. So that's why it's expecting an int, and we cannot upcast it. We cannot what's the exact term? I'm forgetting the exact term, but we cannot upcast it to an int. Byte cannot be upcasted to an int, we have to do that explicitly sometimes, and there are certain compile time mathematics that does compile the byte to the int. But in this case, this is an int, and over here we are passing a byte. That's why it's a mismatch, and it's gonna flag the error that there is a possible loss of precision. So it's not gonna work over here. But say if I do this, I add 1 to it, and now I try to run it. See, this time it's a surprise. There is no error at all. Whereas in the first case we have the possible loss of precision. In the second case, when I add up 1 to it, it becomes perfectly fine. So how this is happening? What's the procedure that is going behind? So what happens is, when you add a byte to an int, in order to match these things up or add these things up, this byte gets upcasted into an int. So at this point over here it becomes an int, and it doesn't remain a byte. So over here it becomes an int, and when it becomes an int, there is no mismatch, right? There is no mismatch. Even if I type in 9 over here to make a match, so that 10 and 100 and 1000 will be onto the screen, as soon as I compile it, it's going to compile, and also we will have the output as 10, 100 and 1000. I hope this point is very much clear, and let's move on to the next point. So the point was, both switch argument and case label can be expression, but case label should be constant expressions. This is a very important point, and it is often asked in the interviews as well. The next point states that every case label should be within the range of switch argument type. So whatever be the case label, case 10, case 100, case 10,000, case 1 lakh, but it should be in the range of the switch argument, the argument which you pass. For example, you have cases up to 10 and you are passing case as 11 and then 12 or say 100, so it will be a problem with the compiler. So to prove or to explain this point further, let me take a scenario. Okay, I already explained it by using the, I think there's this point over there, because over here there's a mismatch in the argument type, and that's why it's going to give the where's that? Yeah, this one is over here, right? So every case label should be within the limits of the argument type. So this was out of the limit of the argument byte, and it was int. That's why it was giving the error, right? Possible loss of precision, we have discussed this point, right? So this is one thing. Now this is also the other part which we have discussed. So this is also gone. Now there is one point also, that duplicate case labels are not allowed, right? Duplicate case labels are not allowed. If you are trying to express case 10 and then again case 10 rather than case 11 or case 100, then it's going to flag the error that it's a duplicate case, please rectify the error. So let me quickly, it's a very straightforward point, but let me quickly run this case. Okay, this is an interesting example over here. So yeah, A and B, and save it. Now if you see the code, you will find that x is equals to 10 over here, right? And we see that there is none of the cases are actually matching. Now this is a constant, remember, this A is not a variable, this is a constant, and this is a character constant. Char literal actually is what is the exact term related to this. Now this A is having the ASCII code as 97, so the compiler is not gonna treat this as A. It's gonna check the ASCII value, and it will find that we already have 97 as the case, so it's gonna flag the error that it is the duplicate case. Let me quickly compile, and we will find that it's a duplicate case label, and it's flagging the error as well, right? So this is the point related to the case labeling and duplication of the case. Now moving on to the next point, I hope there is one point, duplicate case labels are not allowed, so this was the point. Next is case summary. So what are the various points related to the case label? The points that are related to the case label is it should be compile time constant. It should not be a variable. You cannot have x or y over there. Of course you can have, but then you have to declare that variable as a final with the final keyword in order to make that a compile time constant. Right? Now expressions are also allowed, but for case labels expression should be constant. 10 plus 20, it's giving 30, so it's okay. But 10 plus x, it's not gonna give us anything. It will be an expression, and it will not be a constant at compile time, because values are substituted at runtime, and in case of final, the value it will be substituted at the compile time. That's why the using final keyword is not gonna flag any kind of error with the case labels, right? Now the third point states that value should be within the range of switch argument type. So the example that was discussed in that relation was that of byte. We were passing the byte and we were expecting an int, so that's why there was a possible loss of precision issue that was flagged by the compiler. Now the fourth one is duplicate labels are not allowed. This is the latest point which we have discussed. Now this is the case summary related. Next point is fall through inside the switch. How this execution is going through the switch. We have discussed this, but I will be elaborating a little more on this execution because this is important, right? So what's happening? Within the switch statement, if any case is matched, from that case onwards, all statements will be executed. This is what we have already discussed until end of the switch, right? If switch ends come, and it will come out, or break comes in. The break is a keyword which breaks the execution of the loop, and it takes the execution outside the loop. In whichever loop it is happening, or you are executing the break statement, it's gonna come out of that loop, right? It's gonna come out of that loop and will execute from ahead of that loop, right? This is called fall through inside the switch. So the main advantage of fall through inside a switch is we can define common actions for multiple cases. For example, we have a case where we have a marks of the student as 40, or marks of the student as 10, or marks as 50. We will consider all these for professional course as a failure. So we can define these cases from 1 to 50 and at one point and say that all these cases will be a failure. So this is the real advantage of using case compile time constant, and we can put all these things up to 50 into a one statement, case 1 colon, and then leave everything as is, case 2 colon, and leave that, case 3 colon, do not write anything, and up, and like this you can write at case 50 that you can print onto the screen that the student has failed. So if the student has, say, marks 25 over there and the case 25 matches, it will fall through inside the switch and goes up to 50, where it will find a statement stating that the student has failed. So you will find it useful to use such scenarios inside the switch case default syntax. Now let me give you an example related to this. Now we have a class and we have cases. I will be discussing, I have already disclosed the output, but let me quickly run these things in order to make you understand better. So if you see, we have value of x as 0. Now x as 0 is passed over here, so it's a constant. We have all the cases as compile time constant, and we have a default case as well. What's the significance of default case we will be discussing next. But in this program, what is happening is x0 is passed over here, and we are seeing that 0 is matched over here. As soon as 0 is matched, what we will have onto the screen is a 0, right? A 0 will be printed onto the screen, and from this point onwards every statement will be executed. So case 1 will be executed and 1 will be also onto the screen. But as soon as 1 is printed onto the screen, the next statement is break, and the quality of the break is, or the action of the break is, to take out the execution out of that loop. So we will come out of the switch loop. So after break, case 2 will not be executed, and we will come out of the loop and program will exit, right? So this is the output. So 0 and 1 will be the output in case of x is equals to 0, right? So when x is equals to 0, 0 and 1 will be the output, right? And x is equals to 1. So case 0 will not be matched, so this statement won't be executed. But as soon as case 1 gets matched, 1 will be printed onto the screen, and we will again encounter break and we will come out of the loop. So the output onto the screen will be 1. In case of 2, 0 and 1 will never be matched, but case 2 is matched. As soon as this is matched, 2 will be onto the screen, followed by the fall through inside the switch, because there is no break. So default will be also executed, and we will have default onto the screen when x has a value of 2. So that's why default is over there as well. Now when it comes to 3, 2 is not matched. So what's happening is default is getting printed. It means if none of the cases match, then default is a statement which is going to be printed. So it's like a default which will be happening every time if nothing is matching, right? So this is the main working logic of the switch case default. Let me quickly compile and run this. First I will clear the screen and right, compiling the program and running the program as well. 0 and 1 for x is equals to 0. See, 0 and 1 is over here, for x is equals to 0 over there. Now I will change the value of x to 1, and I again have to compile in order to make the changes effective, and 1 is the output over there as discussed over here, right? Now change the output to 2, and we will have next compilation and 2 and default as the output over there, which I have already shown as the output. Similarly, you can check for 3 as like this, and if you see, default is the case. Okay, so this was the point related to the fall inside switch through switch loop, right? Now the last one is the default case. We have discussed the default case. So within the switch we can take the default only once. We cannot take multiple default. We can have multiple cases, but default is the one which is going to be there only once. If no other case matched, then only default case will be executed, right? Now within this switch we can take the default anywhere. It's not necessary to have default in the end. We can have that in the middle or at the beginning of the switch, right? But it is conventional to take default as the last case, so that it becomes clear to you that it will be the last one which will be, or which will always be available. If nothing is being executed, default will be executed automatically. So let me quickly take that and we will print this one, and we will see these scenarios over there. So where is the program? This is the program. Saving it. For x is equals to 0, what's going to happen? We have default over there, right? Now see, what's happening is, because we have a 0, we have a case match, and as soon as the case matches, we print it. So default, although it's standing in the it's standing at the first place, the case gets the priority. So case matches, case gets executed, and from the matching case, the other case will also be executed inside the switch loop, right? So we get the break after case 0. That's why the loop is executed, right? That's why the loop is executed, and we will, let me save this one. Wow. Now that's why 1 is 0 is the output over here in case of x equals to 0 and not the default, right? Now for 1 we have 2 matches, 1 and 2. That's why 2 matches over here. For 2 we have only 1 match. That's why 2 is onto the screen. And for 3 we have a default match. Now what happens is, the position of default is important, because as soon as default gets matched, the statements from there onwards will be executed, right? So what is happening is that default statement is printed onto the screen, which is default, and apart from this, 0 is also executed. For example, if break statement is removed from here, then 1 and 2 will also be onto the screen. You can try it on your own, because I have discussed these falling through inside the switch in the previous example. So I'll leave it to you as an assignment or as a practice, whatever you think. So I hope this is all about the selection statements related to Java. In the next sessions, we will be discussing about the iterative statements inside Java. So thank you very much for listening. Have a great day.